They thought they were invincible. German tank crews in their Panzer III and Panzer IV tanks had rolled across Poland in weeks, crushed France in 6 weeks, and pushed deep into the Soviet Union in Operation Barbarossa. The Wehrmacht's armored forces had proven themselves superior to every opponent they faced. The tactics were revolutionary. Their coordination between tanks, infantry, and air power was unprecedented. They had rewritten the rules of modern warfare. They believed nothing could stop them. Then, on June 23, 1941, near a small town called Rovno in Ukraine, a German tank column encountered something that would fundamentally change their understanding of armored warfare. A massive Soviet tank emerged from cover and opened fire. The first shot destroyed a Panzer IV at over 800 meters. The German tanks returned fire. Their 50mm and 75mm guns hit the Soviet tank repeatedly. The shells bounced off. They literally ricocheted off the sloped armor, leaving only scratches and small dents. The Soviet tank kept firing. Another Panzer IV exploded, then a Panzer III. German tank commanders, veterans of 2 years of nearly uninterrupted victories, experienced something completely foreign: fear. Not the normal combat stress they had trained for, but genuine terror at facing a weapon system against which they had no effective counter. This was the T-34, and it was about to change everything. The story of the Panther tank begins not with German engineering excellence, but with German panic. The panic of realizing that the technological superiority they had assumed was theirs had actually belonged to their enemy. The T-34 wasn't just better than German tanks in 1 or 2 areas. It was comprehensively superior in the 3 factors that mattered most: firepower, armor protection, and mobility. Let me be specific about just how much better the T-34 was, because the numbers are shocking. The standard German medium tank in 1941 was the Panzer IV Ausf F, which weighed approximately 22 tons. Its frontal armor was 50mm thick, arranged vertically. Its main gun was a short-barreled 75mm KWK-37, designed primarily for firing high-explosive shells in support of infantry. Against enemy armor, it was marginal at best. The T-34 model 1941 weighed 26.5 tons. Its frontal armor was also around 45mm thick, but here's the critical difference. It wasn't vertical. It was sloped at 60 degrees from vertical. This seemingly simple design choice meant that a projectile hitting the front of a T-34 had to penetrate not 45mm of steel, but the equivalent of approximately 90mm due to the angle. The armor was twice as effective against incoming fire. The T-34's gun was a 76.2mm F-34 cannon with a long barrel that gave it high muzzle velocity. This gun could penetrate 60mm of armor at 500 meters. At the ranges where tank combat typically occurred on the Eastern Front, between 500 and 1,000 meters, the T-34 could destroy any German tank. The German tanks could barely scratch the T-34. The mobility difference was equally dramatic. The T-34 had wide tracks that distributed its weight effectively, allowing it to cross soft ground and snow that would bog down German tanks with their narrower tracks. It had a powerful V2 diesel engine producing 500 horsepower, giving it a top speed of 53 kilometers per hour on roads. The diesel engine was less prone to catching fire than the gasoline engines in German tanks, and diesel fuel was less volatile and safer to store. German tank crews encountering T-34s in the summer and fall of 1941 were forced to develop desperate tactics. They couldn't penetrate the T-34's frontal armor at combat ranges, so they tried to maneuver to get side shots where the armor was thinner. They called in artillery support. They used 88mm anti-aircraft guns in the anti-tank role because these were the only weapons that could reliably penetrate T-34 armor at range. The psychological impact was devastating. Imagine being a German tank commander who had been told your equipment was the best in the world, who had defeated every opponent with relative ease, suddenly facing an enemy tank that your weapons couldn't hurt while it destroyed your vehicles with impunity. Reports from the front became increasingly alarmed. Unit commanders sent urgent requests for better tanks, better guns, something that could counter this Soviet threat. In November 1941, a German commission, including engineers and military officers, was sent to the front lines to examine captured T-34 tanks and interview crew members who had fought against them. The reports was blunt and alarming. German medium tanks were inferior to the T-34 in every significant category. Immediate action was required to develop a counter. The German Army Weapons Department, the Waffenamt, issued specifications for a new medium tank in January 1942. The requirements reflected hard lessons learned in Russia. The new tank would have sloped armor for better protection without excessive weight. It would mount a gun capable of defeating the T-34 at combat ranges. It would have wide tracks and good mobility for operations in all terrain and weather conditions. And it would incorporate reliability features that German tanks, often over-engineered with complex systems, frequently lacked. Two companies received contracts to develop prototypes. Daimler-Benz, which had extensive experience building tanks and was already producing the Panzer III and Panzer IV, submitted a design that was basically a German copy of the T-34. It had sloped armor all around, a diesel engine, and even copied the large road wheels of the Soviet design. The Daimler-Benz design was designated VK30.01DB. MAN, Maschinenfabrik Augsburg-Nuremberg, submitted a more conventional German design. It retained some traditional features like torsion bar suspension and a gasoline engine, but incorporated the critical innovation of sloped armor and a powerful new gun. This was designated VK30.02 MAN. In May 1942, after reviewing both prototypes, Hitler and the weapons department selected the MAN design. The reasons were partly technical and partly political. The MAN design could use existing components from other German tanks, making production easier. It had better crew ergonomics than the cramped Daimler-Benz design, and, perhaps most importantly, it looked German. The military leadership was uncomfortable with a design that so obviously copied the enemy. The selected design would become the Panzerkampfwagen 5, or Panther. Production was ordered to begin immediately, with the first tanks to be delivered by December 1942. This was an impossibly aggressive timeline for a completely new tank design, but the situation on the Eastern Front was desperate. German forces had been stopped outside Moscow in December 1941. The summer offensive of 1942 was pushing towards Stalingrad and the Caucasus, but Soviet resistance was fierce. Germany needed better tanks, and it needed them now. The Panther that emerged from this rushed development was a remarkable machine, a quantum leap forward in German tank design. It weighed 44.8 tons in its early versions, nearly twice the weight of the Panzer IV, but that weight brought capabilities that German tank crews desperately needed. The armor was revolutionary for German design. The front hull was 80 millimeters thick, sloped at 55 degrees from vertical. This provided effective protection equivalent to approximately 140 millimeters of vertical armor. The front of the turret was 100 millimeters thick, with rounded geometry that made it even more resistant to penetration. Side armor was 40 to 50 millimeters, thinner than the front, but adequate against most threats from the flank. Even the top armor was 16 to 25 millimeters, enough to resist most artillery fragments and light anti-aircraft fire. The gun was the 75mm KWK-42L70. That designation meant it had a barrel 70 calibers long, or 5,250 millimeters from breech to muzzle. This extremely long barrel gave the gun exceptional muzzle velocity, around 935 meters per second with standard armor-piercing ammunition. At 1,000 meters, the distance of a typical engagement, the KWK-42 could penetrate 124 millimeters of vertical armor plate. At 2,000 meters, it could still penetrate 89 millimeters. This gun could destroy any Allied tank in service at ranges where the Allied tanks couldn't effectively return fire. The Panther's mobility was impressive for its weight. It used a Maybach HL230P30 gasoline engine producing 700 horsepower at 3,000 revolutions per minute. This gave the 44-ton tank a power-to-weight ratio of about 15.6 horsepower per ton, better than most heavy tanks of the period. Top speed was 46 kilometers per hour on roads, and the tank could maintain 25 to 30 kilometers per hour cross-country. The wide tracks, 660 millimeters, distributed the weight well and gave good ground pressure of only 0.88 kilograms per square centimeter, actually better than the T-34 despite being much heavier. Inside, the Panther had a crew of 5. The driver and radio operators sat in the forward hull. The driver had a complex set of controls, including a 7-speed gearbox that was advanced but notoriously difficult to master. The radio operator manned a hull-mounted MG-34 machine gun and operated communication equipment. In the turret, 3 men worked in relatively spacious conditions compared to earlier German tanks. The commander had a cupola with 7 periscopes providing all-around vision. The gunner had an excellent TZF-12 telescopic sight with 2.5x and 5x magnification. The loader had organized ammunition racks and enough space to maintain a good rate of fire. This was the tank that was supposed to restore German superiority on the battlefield. On paper, it was magnificent. In practice, the rushed development and desperate production schedule would create problems that haunted the Panther throughout its combat life. The first Panthers rolled off the production line in January 1943, a month behind the already aggressive schedule. The delays were caused by constant design changes as engineers tried to fix problems discovered during testing. The initial production tanks had engines that overheated. They had transmissions that broke down after minimal use. They had fuel systems that leaked. They had electrical problems that left them immobile. These were not minor teething troubles. These were fundamental reliability issues that should have been resolved before mass production began. But Germany didn't have time for proper development. The situation on the Eastern Front had become catastrophic. The German Sixth Army had been destroyed at Stalingrad in February 1943. Soviet forces were pushing westward. Germany needed the Panther in combat immediately, regardless of its readiness. The German High Command decided to commit the new Panthers in a massive offensive operation that would demonstrate German armor superiority and hopefully regain the initiative in the East. This operation was codenamed Unternehmen Citadelle, Operation Citadel. The target was a large Soviet salient around the city of Kursk. The plan was to attack from both north and south, cut off the Soviet forces in the salient, and destroy them in a massive encirclement. It would be the largest tank battle in history. For the operation, Germany assembled approximately 2,700 tanks and assault guns. This included every available Panther, 200 tanks, organized into 2 battalions. These Panthers were supposed to be the spearhead, the elite units that would smash through Soviet defenses and prove that German engineering had answered the T-34 threat. The attack began on July 5, 1943. Almost immediately, the Panthers began breaking down. Engines caught fire, transmissions seized, fuel pumps failed, drive sprockety broke. Of the 200 Panthers committed to the initial assault, only about 140 actually crossed the start line. By the end of the first day of combat, only 40 Panthers were still operational. The rest were broken down, destroyed by enemy fire, or burning from engine fires. These technical failures were catastrophic, but not entirely unexpected given the rushed development. What was unexpected was how the Soviets had prepared for the German attack. Soviet intelligence had learned about Operation Citadel months in advance. They had fortified the Kursk salient with overlapping defensive lines, minefields, anti-tank guns, artillery, and carefully positioned armor reserves. They were ready. German forces, including the Panthers that remained operational, pushed forward against fierce resistance. The Panthers that did work performed well in combat. Their guns could destroy Soviet tanks at long range. Their armor resisted most Soviet anti-tank fire. But mechanical failures continued to plague the formation. After a week of fighting, the offensive had gained minimal ground at enormous cost. On July 13th, Hitler canceled Operation Citadel. For the Panther battalions, the Battle of Kursk was a disaster. Of 200 Panthers committed, 162 were lost. Some were destroyed by enemy fire. Many more broke down and had to be abandoned when recovery was impossible. The new wonder weapon had failed its first major test. After Kursk, German engineers worked frantically to fix the Panther's reliability problems. The engine cooling system was redesigned. The transmission was strengthened. The final drive units, which had been breaking under the tank's weight, were reinforced. Fuel system leaks were addressed. By late 1943, Panthers rolling off the production line were significantly more reliable than the early models. They still weren't as reliable as they should have been, but they were functional combat vehicles. As improved Panthers reached frontline units, their combat reputation began to shift. When the tanks worked, they were devastating. Allied tank crews learned to fear the Panther. Its gun could penetrate Allied armor at ranges where return fire was ineffective. Its armor could withstand hits from most Allied tank guns at combat ranges. Its mobility allowed it to position effectively and retreat when necessary. In Normandy, after the Allied invasion in June 1944, Panthers became the backbone of German armored defense. A single Panther in a good defensive position could hold up an entire Allied tank squadron. British and American tank commanders developed healthy respect for the German Cat tanks, the Panther and Tiger series. The British 75mm gun mounted on Sherman and Cromwell tanks could not reliably penetrate a Panther's frontal armor at any combat range. The armor was simply too thick and too well sloped. British tankers had to maneuver to get flank shots, use superior numbers to overwhelm German positions, or call in artillery and air support. Fighting Panthers was a dangerous, costly business. American tank crews faced the same problem. The standard M4 Sherman with its 75mm gun was outmatched by the Panther. American doctrine emphasized numbers, calling in artillery, air support, and infantry cooperation to deal with superior German armor. But in direct tank versus tank engagements, the Panther had a significant advantage. One American tank commander later described an encounter with a Panther near the town of Saint-Lô. His platoon of 5 Shermans spotted the German tank positioned at a crossroads about 800 meters away. The Shermans opened fire. They scored multiple hits on the Panther's front armor. The shells bounced off, creating sparks, but no penetrations. The Panther traversed its turret with mechanical precision and fired. The first shot destroyed the lead Sherman, killing the entire crew. The second shot hit another Sherman, setting it on fire. The remaining 3 Shermans retreated behind buildings, called for artillery support, and waited. They couldn't fight the Panther directly. They needed heavier weapons. Stories like this spread through Allied tank units. The Panther gained the reputation as a nearly invincible opponent in frontal engagements. This reputation was somewhat exaggerated, but not entirely undeserved. The Panther was simply a better tank in many respects than what the Allies were fielding in 1944. But the Panther had weaknesses that became increasingly apparent as the war continued. The side and rear armor, while decent, was vulnerable to most Allied anti-tank weapons. American M10 and M36 tank destroyers, with their 76mm and 90mm guns, could penetrate Panther armor from the side. British 17-pounder anti-tank guns could penetrate the Panther's frontal armor at closer ranges. And most critically, the Panther remained mechanically complex and prone to breakdowns. The final drive units, even after redesigned, remained weak points. These were the gears that transferred power from the transmission to the drive sprockets that moved the tracks. The Panther's weight and the power of its engine put enormous stress on these components. After 150 kilometers of operation, final drives often needed replacement. In combat conditions, with poor maintenance facilities and limited spare parts, this was a serious problem. German crews learned to be gentle with their Panthers, to avoid sharp turns at high speed, to use careful throttle control, to perform meticulous maintenance whenever possible. But in combat, you couldn't always be gentle. Sometimes you needed full power to escape an artillery barrage. Sometimes you needed to turn sharply to present your front armor to a flanking threat. The mechanical fragility of the Panther meant that aggressive maneuvering could disable your own tank without enemy action. The production history of the Panther reveals both German engineering capability and the strategic problems Germany faced. From 1943 to 1945, German industry produced approximately 6,000 Panthers. This was an impressive number for such a complex vehicle built under wartime conditions, with increasing Allied bombing disrupting production. Several manufacturers were involved. MAN, the original designer, produced about 2,300 Panthers at facilities in Nuremberg. Daimler-Benz produced around 2,100 at plants in Berlin. MNH, Machine and Fabric Niedersachsen-Hanover, produced about 1,150. Henschel contributed smaller numbers. But 6,000 tanks spread over 2.5 years of war on multiple fronts, facing enemies who vastly outnumbered Germany, was not enough. Compare this to Allied production. The United States alone built over 49,000 Sherman tanks. The Soviet Union built over 84,000 T-34s in various models. Britain produced thousands of Churchills, Cromwells, and other tanks. Germany was drowning in Allied steel. The strategic situation meant that Panthers were always outnumbered, usually heavily. In Normandy, Germany could field perhaps 200 Panthers against thousands of Allied tanks. On the Eastern Front, even at the peak of Panther production, German armored units were outnumbered 3-1 or more by Soviet forces. This numerical disparity meant that even when Panthers achieved favorable kill ratios, destroying more enemy tanks than they lost, the Germans were still losing the war of attrition. A Panther might destroy 3 or 4 Shermans before being knocked out or breaking down, but the Allies could replace those Shermans. Germany could not replace the Panther. The training crew situation made things worse. In the early war, German tank crews received extensive training, sometimes 6 months or more, before being sent to combat. By 1944, with desperate personnel shortages, training periods were cut to weeks. New crews received their Panthers and went straight into combat with minimal experience. They didn't know the tanks well enough to maintain them properly. They didn't know how to position them effectively or when to retreat. They made mistakes that veterans wouldn't make, and they died in their technically superior tanks because they lacked the experience to use them effectively. One of the most famous Panther engagements occurred in July 1944 near the village of Villers-Bocage in Normandy. A single Panther commanded by SS Oberscharführer Ernst Bachmann engaged a column of American tanks and vehicles. Bachmann positioned his Panther at a crossroads with good cover and clear fields of fire. When the American column appeared, he opened fire methodically, destroying tank after tank. Over about 15 minutes, Bachmann's crew destroyed 9 Sherman tanks and multiple other vehicles before withdrawing. The Americans, unable to pinpoint the Panther's position quickly enough and facing superior firepower, suffered heavy losses. This engagement became legend in both German and American armor circles. It demonstrated what a well-handled Panther could do in ideal conditions with a good crew and proper positioning. But it was not typical. Most Panther crews were not Ernst Bachmann. Most combat situations did not provide ideal defensive positions with clear fields of fire and covered withdrawal routes. More typical was the experience of countless Panther crews who fought, were overwhelmed by numbers, ran out of fuel, broke down mechanically, or were destroyed by air attack. Allied air superiority over both Normandy and the Eastern Front meant that German armor moving in daylight was vulnerable to fighter bombers. American P-47 Thunderbolts and British Typhoons with rockets could destroy Panthers. Soviet Il-2 Sturmovik ground attack aircraft were equally deadly. The Panther's top armor, while better than most tanks, could still be penetrated by rockets and heavy cannon fire from above. The final year of the war, 1945, saw Panthers fighting desperate defensive battles across shrinking German territory. On the Eastern Front, Soviet offensives pushed westward with overwhelming force. Panther units fought delaying actions, trying to slow the Soviet advance while German civilians evacuated and remaining Wehrmacht units retreated. On the Western Front, after the failed Ardennes offensive in December 1944, Germany was on the defensive everywhere. Panthers continued to exact heavy tolls on Allied armor when properly employed, but there were never enough of them. Fuel shortages meant tanks sat immobile, used as stationary pillboxes because there was no fuel to move them. Ammunition shortages meant crews had to conserve rounds, firing only when they were certain of a hit. Spare parts shortages meant that minor breakdowns turned into permanent losses because there were no replacement components. By April 1945, as Soviet forces closed on Berlin and American forces crossed the Elbe River, most surviving Panthers were abandoned by their crews. Some ran out of fuel. Some broke down. Some were destroyed in the final battles. A few were surrendered intact when their crews gave up, rather than face certain death in hopeless combat. After the war ended, Allied forces captured hundreds of Panthers in various states of repair. These tanks were thoroughly examined by American, British, and Soviet engineers. The reports make fascinating reading. They praised the Panther's firepower and armor protection. They noted the excellent gun sight and good crew ergonomics.
They also documented in detail all the mechanical problems, the weak final drives, the complex and failure-prone transmission, the engine cooling issues, the fuel system problems. They actually tested captured Panthers extensively, running them at their Bovington proving grounds. The trials confirmed what German crews had experienced. The Panther was fast and powerful when it worked. It could also be temperamental, requiring skilled crews and good maintenance to keep operational. British tankers concluded that while the Panther was impressive, they preferred their own tanks. Despite inferior firepower and armor, the British tanks were more reliable, easier to maintain, and could be produced in larger numbers. The Soviets were perhaps most interested in the Panther. They examined captured examples carefully, looking for features to incorporate into their own designs. Soviet engineers respected the gun and the sloped armor, though they noted that Soviet tanks had pioneered sloped armor years before Germany adopted it. They were less impressed by the complexity and the reliability problems. Soviet design philosophy emphasized simplicity, reliability, and mass production. The Panther was too complex, too difficult to build in the quantities modern war required. This gets to the fundamental problem Germany faced with tanks like the Panther. Germany tried to counter Allied numerical superiority with technological superiority. If one Panther could destroy 3 Shermans, then Germany only needed to build 1 Panther for every 3 Shermans the Allies built. But this logic failed because it assumed that all Panthers would be operational, properly crewed, supplied with fuel and ammunition, and employed effectively. In reality, mechanical breakdowns, fuel shortages, crew quality variations, and battlefield chaos meant that the theoretical superiority didn't translate into consistent battlefield dominance. The Panther's complexity also made it difficult to produce quickly. A Panther required approximately 55,000 man-hours to build, compared to about 10,000 man-hours for a T-34 or about 8,000 for a Sherman. German factories could build 1 Panther in the time Allied factories built 5 or 6 tanks. The quality of those German man-hours was high. German manufacturing was precise and skilled, but quantity has a quality of its own, as Stalin reportedly said. There's another factor often overlooked in analyses of the Panther and German armor in general. Germany was fighting a 2-front war by 1944. Actually, multiple fronts if you count Italy and the Balkans. Panthers had to be divided between these fronts. Units on the Eastern Front needed Panthers to counter Soviet armor. Units in France needed Panthers to resist the coming Allied invasion. Neither front had enough. If Germany could have concentrated all Panthers on one front, the impact would have been much greater. But strategic necessity meant dispersing this limited resource. The Panther also suffered from Hitler's interference in tank development and production. Hitler was fascinated by military technology and insisted on being involved in design decisions. He pushed for heavier armor, bigger guns, more complex features. These demands increased development time, production costs, and mechanical complexity. Some of the Panther's problems can be traced directly to requirements that Hitler imposed, features that engineers knew would cause issues but were ordered to include anyway. There's a counterfactual question that historians sometimes debate. What if Germany had focused on producing large numbers of simpler, more reliable tanks instead of complex designs like the Panther? What if they had built an improved Panzer IV with better armor and gun, but maintaining mechanical simplicity? Could they have produced these in numbers sufficient to offset Allied advantages? The likely answer is no. By 1943 and 1944, Germany's industrial capacity was simply overwhelmed. Allied bombing was disrupting production. Raw material shortages were increasing. Labor shortages meant using forced labor and unskilled workers, reducing quality and productivity. Even if Germany had designed the perfect medium tank, simple, reliable, and effective, they still couldn't have built enough to matter strategically.
But the Panther represents something important beyond its tactical and strategic impact. It represents the apex of a certain kind of military engineering philosophy. German engineers believed that superior quality could offset numerical disadvantages. They believed that careful design, precision manufacturing, and sophisticated technology would create weapons systems so effective that they would multiply force and allow smaller numbers to achieve victory. This philosophy worked to some extent. The Panther was feared by its opponents. It achieved impressive kill ratios in many engagements. Individual crews with skill and luck accomplished remarkable things. But it wasn't enough. The philosophy failed because modern industrial warfare is fundamentally about resources, production capacity, and sustainability. The side that can build more tanks, train more crews, supply more fuel and ammunition, and replace losses faster will win the grinding war of attrition. The legacy of the Panther continued after World War II. The tank influenced post-war designs in multiple countries. The French built the AMX-50, which borrowed features from the Panther. The Soviets incorporated lessons from captured Panthers into their post-war tank designs. The British studied the Panther when developing their Centurion tank. Even the Americans, though they had moved away from the Sherman toward new designs like the Pershing and Patton, examined Panther features and incorporated some concepts. Today, surviving Panthers are prized museum pieces. The Bovington Tank Museum in England has one. The Patton Museum at Fort Knox had one before it moved to Fort Benning. The Kubinka Tank Museum in Russia has several. Museums in France, Belgium, and Germany display Panthers that were recovered from battlefields or salvaged from training grounds. These survivors, carefully restored and preserved, allow new generations to see what German tank crews fought in during the desperate final years of World War II. The Panther was a remarkable machine. Probably the best medium tank design of World War II in terms of the balance between firepower, armor, and mobility. But it was also a symbol of Germany's strategic failures. It came too late. It was too complex. It couldn't be produced in sufficient numbers, and no amount of technological superiority could overcome the fundamental disadvantages Germany faced, fighting a multi-front war against enemies with vastly greater resources and industrial capacity. For the German tank crews who fought in Panthers, the experience was bittersweet. They had a weapon that was often superior to what they faced. They could destroy tank enemies at ranges where they were relatively safe. They had protection that saved their lives in situations where earlier German tanks would have been death traps. But they also knew they were outnumbered, undersupplied, and ultimately losing. They knew that for every Panther Germany produced, the Allies produced 10 tanks. They knew that mechanical reliability problems could leave them stranded and vulnerable. And they knew that the war was lost, even if their individual tank was still fighting. The story of the Panther is ultimately a tragedy. It was a magnificent piece of engineering that came from desperation, rushed into production before it was ready, thrown into battles where numerical superiority mattered more than technical excellence, and finally abandoned on roadsides across Europe as Germany collapsed. The tank that was supposed to restore German armor supremacy ended up as another symbol of how Germany could win battles but lose the war, could achieve tactical excellence but fail strategically, could build remarkable weapons but lack the resources to use them effectively. The lessons from the Panther remain relevant today. Technology matters in warfare, but it's not everything. Reliability, maintainability, and producibility are as important as raw performance. Numbers matter. Logistics matter, crew training matters, and strategic decisions about resource allocation matter more than any single weapon system. The next time you see a Panther in a museum, restored and impressive, remember that it represents both the peak of German World War II tank design and the limits of what technology alone can accomplish in war. It was a great tank. It wasn't enough.